This is the last in a series of videos in which I've been repairing and restoring this HP9862A calculator plotter. It's now fully functional. I've got the plotter itself working. I've still got a bit of work to do on it, just replacing some knobs, and as soon as I find some replacements I'll just swap the ones that it has on. Apart from that, it's finished. I had to do quite a bit of work on the electronics, but not too much. Most of it was in the physical plotter itself. The mechanics and the plotting surface needed to be replaced. So that's all done. I then had to make up an interface for it. I didn't have the interface cable and the card that fits into the back of the calculator. So in the previous few videos I've gone through making one of those up. That's now fully tested and it's working fine, no problems with it at all as far as I can tell. This calculator, it's not the one you've seen before. This is one that needs some repairs, so it does have a few issues, but I'm using this simply because it's in the lab and I don't want to have to cart in the other one. They're quite heavy, so I thought I might as well try and use this one. There will be some upcoming videos on the repair of this machine in the future. But in this video I just want to do a final test, and we'll plot a few things just to make sure that the interface works. So it's all plugged in, and I've got a simple program entered into the calculator. It doesn't really do very much, it's just going to draw a straight line. So we'll put a piece of paper in and run the program, and in theory we should lower the pen, draw a straight line and then come back to the origin. Hopefully you're going to be able to see this okay. The camera is not very good at picking up high contrast images, so I'm not quite sure how well this will come across, but hopefully you'll be able to see what it's drawing. So we'll run the program, and as you can see, let's get the out of the way. So as you can see, or hopefully you can see, it's drawn a nice straight line, and it is a straight line, so we're not kind of missing any bits or anything. The length of this line is sufficient to use all 8 bits of the resolution. So the data sent from the calculator for each of the axes is a 16-bit number, and it's sent in 2 8-bit chunks. So if there was a bit sticking, you'll find that what you'll get is a sudden jump in the lines you're trying to draw. So that's now working. We'll just run it again just to make sure it's working consistently. And as you can see, it works fine. So what I'm going to do now is just enter a slightly more ambitious program, and we'll try and print something or plot something a bit more interesting. Okay, I've entered a simple test program into the calculator just so I can draw some simple graphics. We'll put a fresh piece of paper into the plotter, run the program, Okay, so as you can see, the interface is working properly. It's communicating between the calculator and plotter without any problems. It's drawing some very nice graphics, so it's nice straight lines. It's still a bit growly, so I need to give the potentiometers another clean, but as you can see, it is now fully functional. And what I'll be doing now is just experimenting, writing some simple programs to test this further, and hopefully you found this series interesting. It's been quite an interesting challenge getting a plotter like this working, especially because the interface was missing. And so we'll have a quick final look at the interface, and that will be the end of this series. Okay, so that's the finished interface, and the important thing is, of course, that it works. And what I was trying to achieve here was something that looked a little bit like an original, and hopefully you'll agree that it does look reasonably authentic. It's not absolutely, it's not going to fool anyone, but that's not the intention. It was just to get something that looked like the original units, and of course is functional, and this is now working. So that was my main goal, and in the long run it worked out about 1/10 of the cost of buying one off eBay. So it's well worth it in terms of saving money. As I said, that's not to say that the genuine ones aren't worth what they're being sold for. They are rare, but if what you wanted was what I wanted, which is just to get the plotter working, then this is a valid alternative. And I will be making these boards available on my website if you want to build one of your own. As ever, unfortunately I can't provide technical support, but it is a reproduction board, so any information that relates to the original will also relate to this. So all the parts that fit onto this are quite easy to get hold of, apart from IC2, which is a 93L14. It's basically a quad latch, but it's got a fairly odd pin out. I did look for alternatives that I could drop in, but really there aren't any. So I have acquired a quantity of these, so I'll be putting these on my website as well. You can still get them, but normally you've got to buy quite a few to get anything approaching a sensible price. So all the rest of the parts you can get quite easily from pretty much anywhere, but because this is rare, I will put the ones I have onto my website. Okay, so that's it for this project. Hopefully you found it interesting. If you do want to see any particular demonstrations with the calculator and plotter, then please let me know. And you may have noticed the calculator I was using is not the same one that you've seen in my previous videos, so that will be the subject of an upcoming restoration. It does have some faults, so I need to get it repaired. And I have another one as well, so there's a couple of HP9862A restorations and repair series coming up. But as I say, if you want any particular demonstrations with this, then please let me know.